Let's try to illustrate the concept of sorting problem. Typically, like we try to solve an algorithm like insertion sort. So first, we should have an input array. This is the sequence of n numbers that need to be sorted, which denoted as A1, A2, blah, 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 until An. The sorting process, which is transform the input array into the output array. Then we get the sorted array, with each element is non-decreasing order, so it is a permutation, which is reordering of the input sequence, such that we have A'1 less than A'2 less than blah 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 less than A'N. And let's talk about the terminologies we use in the sorting algorithm. So first is keys, which is the individual numbers that in the array we need to be sorted. And the second is satellite data, which is any associated data that is related to the keys. For example, if the keys are employee IDs, then the satellite data could be the corresponding names, addresses, and etc. And the third is record, which is combination of keys and is satellite data. So it is important that many applications where the data is associated with keys, but they must maintain associated with them after sorting. So each row represents a record which containing all the data for a single student, and the GPA column is chosen as the key for sorting. So when we sort the records by GPA in descending order, we move the entire row, which is the record. And so the satellite data, which include age, course they taken, all of them are associated with the GPA key, which stay with it. It is important that the integrity of the record is maintained, which meaning the age and courses that taken are corresponding to each student ID, which remain with the GPA as it's sorted. Although we are focused on the keys, in this case, which is GPA. So when we try to describe this sorting algorithm, the satellite data like age, student ID, and courses they taken is also rearranged to maintain the relationship between the keys and the corresponding data. So in this sorting algorithm, the complexity comes from not just from the sorting the key, but we have to ensure that the satellite data so that we can remain correctly associated with its respective key. Let's try to illustrate the steps of insertion sort algorithm. So we will use the analogy of sorting playing cards. The first step is all cards are initially in the pile and the hand is empty. The first card is moved from the pile to our hand, and this single card is trivially sorted, and then the second card is picked from the pile. It needs to be compared with the cards in my hand, which is starting from the right to left, and it then inserted to the correct position. The fourth card is taken from the pile and inserted into its correct position in sorted hand, and finally, the last card is sorted into our hand, and at this point, the pile is empty and all cards are sorted in our hand. Throughout these steps, we maintain a sorted order in the left hand, and each new card from the pile is inserted into its correct position in the sorted set. So this is a sense of insertion sort, which maintaining a sorted subset, and we can expanding it one element at a time by inserting new elements into the correct positions. So we just visualized and explained the concept of insertion sort by using the analogy of sorting a hand of playing cards, right? And we already assume we have a small set of cards, each card with a distinct value, and go through the steps. First, the initial state is we start with all cards in a pile, and we move the first card into our left hand and leaving it sorted by itself. And then we pick the next card with our right hand and compare it with the cards in our left hand, and we're starting from the right to left. So depending on its value, we insert this card to its correct position in our left hand, and we continue this process for each card in the pile, and always inserting each card into its correct position into our left hand. So the current card being sorted and its comparison with the sorted card in our left hand.